Okay, this is part 4 of our chapter 2, module 2 series of videos that you're doing at home. This is the last one. And this one is all about direct variation. You did direct variation when you were in 8th grade. This is all about proportions. Proportional values can be written as linear equations, and let me show you why. If you had 3 over 4 equals x over 8, you could write that as a linear equation in the sense that if you were to cross multiply, you would get 24 equals 4x. So if you didn't know what one of these other variables were, it would be a y. So if it was y over 4 equals x over 8, and you cross multiplied, that would give you 8y equals 4x. If you divided by 8 on both sides, that would give you y equals 1/2 x, which is slope-intercept form. The y-intercept is 0. So anyway, you looked at proportions in this way, but in Algebra 1, you should have looked at them as direct variation. You may have skipped this section in Algebra 1. They may have just gone over proportions like you were used to. Okay, so in direct variation, x and y, let me erase this while I'm talking. X and y denote two quantities. Y is directly proportional to x, or y varies directly with x. If there exists a non-zero number k such that if you write the linear equation, it's y equals kx, and that's what we just got. We got y equals, and I don't remember what it was. Oh no, I do. It was 1/2 x. So 1/2 would have been that k value, that constant of proportionality. So the number k is called the constant of proportionality, or the constant of variation. And I just want to put what they just said in layman's terms. In layman's terms, it says, if the x increases, the y is also going to increase. If the x decreases, the y is also going to decrease. And how is it going to increase? Well, it's going to decrease. It's going to increase or decrease based on what that constant of proportionality is. So, for example, just a pretty quick example, if I had y equals 2x, this constant says that I'm going to make things get bigger, because I'm going to take what x is, and as it gets bigger, I'm going to keep multiplying it by 2, which means that the y is going to also keep getting bigger. All right, if x got smaller and smaller and smaller, and I kept multiplying it by 2, then that y would also get smaller. Okay? All right. So that's my version of what this whole definition, including this part, is telling you. So what if we had a fraction, 1/2 x? Well, still, if x is getting bigger, the y is getting bigger, because if x is 2, then the y would be 1. If x is 4, 4 times 1/2, y would be 2. So see, as x gets bigger, the y gets bigger. And this is the constant of proportionality, which tells you how to get between the two. So let's keep moving. All right, here's an example. Hooke's law states that the distance an elastic spring stretches beyond its natural length is directly proportional, there's your key word, to the amount of weight hung on the spring. The constant of proportionality is called the spring constant. Thus, if a weight of force F is applied and the spring stretches a distance k beyond its natural length, then the equation F equals k of x models the situation where k is the spring. So F is the force applied, k is that constant that's telling you how much it's growing by, and x is the pounds of the weight that we're putting in. So here we go. So if a 12-pound weight is hung on a spring and it stretches 2 inches, then let's first find the spring constant. So we're going to take that formula that they basically told us for the situation, and we're going to plug in what we know. Okay, that's an x, I'm sorry. Let me fix that. Okay, we're going to plug in what we know. We know that the force is the weight, and that's 12 pounds. We know that x is how much it stretches, and that's 2 inches. So we're going to let 12 be F. We don't know that constant yet because they didn't tell it to us up here. They just told us the weight and how much it stretches. And so we know that our x is 2. Well, we can solve to find k. We can divide by 2 on both sides. So our constant in this equation, in this situation, is 6. So that's the spring constant, or that, where do they write it? The constant of proportionality that they wrote up here. They also, in this situation, they called it a spring constant. Okay, so the question is, determine how far the spring will stretch when a 19-pound weight is hung on it. So here's the deal. Once you know that constant of proportionality, which is this part right here, well, then you can take your equation that they gave you. That constant of proportionality is not going to change. It's going to stay the same throughout all the problems you do of this type. So I'm going to plug in a 6 for that constant of proportionality. It's going to be force equals 6x. Now you can solve the problem for anything they give you. So a 19-pound weight, that would be the force for pounds, equals 6x. So how far is the spring going to stretch? Well, we'll divide by 6 on both sides, and it's going to stretch 19 over 6 inches. I could give you anything. I could say the spring is going to stretch 10 inches. How much weight would make that happen? And you would take your equation, F equals 6x, plug in 10, and you would know that it would take 60 pounds of weight to make it stretch that far. So once you find your constant of proportionality, then you can do any problem you want because you plug it into the equation. All right, example 2. Let t vary directly with x, and suppose that t equals 33 when x equals 5. Find t when x equals 31. Okay, so the equation is, since t varies directly with x, that's telling me that t equals that portion of constant of proportionality times x. And we'll go through the same steps again. They told us that t is 33. They told us that that happens when x is 5. So we'll put a 5 in for our x. We're going to divide by 5 on both sides. So our constant of proportionality is 33 over 5. So this means that our equation is really t equals 33 over 5 times x. They wanted us to find the answer when x is 31. So we have 33 over 5 times 31. And we solve this, which is going to give us t equals 204.6. Okay, in your quiz this weekend, I believe that the majority of the problems are just basic 8th grade proportional problems. You can set them up as a regular proportion, which is what you're probably going to do anyway, but you also can set them up using this kind of situation where you make an equation that matches. All right, we are done.